Welcome guys. So as you can see here, we have a graph of a quadratic equation. We're asked to find the sum of the magnitudes of its complex roots. So first we need to find the equation, then make sure they're complex. But before we find the equation, we can actually figure out whether they're complex or not. Just notice the graph. As you can see here, this curve does not intersect with the x-axis, so it has no real zeros. So all roots will be either complex or imaginary. And as for the quadratic equation, let's pull out some good points. Then we can make a system of equations and solve them. And to make it easier, to make the system of equations much easier, you can pull out some nice points. So let's take -1, 0, and 1. These things can help you eliminate variables easily. So for -1, we have 9. And for 0, we have 4. And whenever you plug in 0 into a quadratic equation, you always get the constant because all the other terms become 0. And as for 1, we have 5 over here. Later in the video, you'll get to notice how easily we can eliminate most of the variables and find the equation very quickly. And as for the sum of the magnitudes, you can check the shorts I posted previously. It's in the description below. You can click on the link. It has the complete explanation of how to find the sum of the magnitudes along with the derivation. So all we need is actually C by A, but we'll be using the discriminant method later in the video. So let's see how it works. So this is the arrangement we have left. F of 0 is 4, f of 1 is 5, and f of minus 1 is 9. So if we take a look at each equation, we can solve the system of equations. So we have this one. So a into 0 squared is a into 0, which is 0. So forget this. B into 0 is 0. And we have c, which is 4. So this implies c equals 4. Taking this one, we get a into 1 squared, which is a, plus b into 1, which is plus b, plus c, which is 4. So plus 4 equals 5. This implies a plus b is 1, because if you take 4 this side, we get 5 minus 4, which is 1. So a plus b equals 1. Next we have this one, which is f of minus 1 equals 9. So a into minus 1 whole square, which is a into 1, which is a. Then b into minus 1 is minus b, and c is 4. And this equals 9. If we take 4 this side, we get a minus b equals 5. Equals 5. Now here they asked us the sum of the magnitudes of the complex roots of f of x. We don't know how many complex roots this equation has, so we have to verify that b squared is greater than or equal to 4ac. If it satisfies this condition, then it gives only one or more real roots. Otherwise, it'll give us complex roots. So we can solve this equation then. So to make sure they're complex, b squared has to be lesser than 4ac. This is important. So now let's solve it. Now a plus b equals 1, a minus b equals 5. If you solve this, you get, let's add up the equation. So we have 6 equals plus b minus b cancel out each other. So we have 2a equals 6, a equals 3. And if we subtract this equation from this equation, a cancels this a out because this is minus. So let's put a minus here. This is minus a, and minus of negative b is plus b, equals 5. So equals minus 5, by the way, because we were multiplying by minus 1 on both sides here. Now if you add the equation, you simply get, this cancels this out, and this becomes minus 4. So 2b equals minus 4, that implies b equals minus 2. Now this is the equation, coefficients we have. So the equation was actually 3x squared minus 2x plus 4 equals 0. So basically this is actually derived from the quadratic formula, where b is supposed to be a real number. So let's take a look at the root. B squared minus 4ac. So 4ac is greater than b squared. This will end up being a negative number, and we'll end up getting imaginary or complex numbers. So substituting these values here, we can see that b squared, which is 2 squared, which is 4, is actually lesser than 4 times 3 times 4, which is going to be 16 times 3, which is 48. This is true. So that means both roots are complex. So now we know that both roots are complex. Now it's just a matter of substituting the formula given in the shorts I posted previously. So that was 2 root c. It is actually 2 root alpha beta. So you don't have to solve for alpha and beta from this equation. That'll waste our time. So what we want to do is use Vieta's formula, which states that in a quadratic equation, the product of the roots will be equal to the constant. But this actually works only if the x squared's coefficient is 1. So if the x squared's coefficient is not 1, we'll have c by a. So now substituting in this thing, 2 root c by a, which is 2 root c is 4 and a is 3. So we have 2 root 4 by root 3, which is, we have to take the positive square root here. So root of 4 is 2. 2 times 2 is 4. 4 by root 3. Now let's rationalize the denominator. By multiplying both sides by root 3, we get 4 root 3 by 3. That gives us 4 by 3 times root 3. So this is your answer. Hope you enjoyed this video. Thanks for watching. For more such videos, subscribe to my channel. Stay tuned for the next episode. Until then, see you soon. Goodbye.